we're engineers. We design buildings. As engineers, we try to be glass half full people. We want to solve problems, not create them. Sometimes we fail. Sometimes we win. And what we're going to try and talk about this afternoon is some success stories and how we are combating this fact that we're designing buildings which are thermally active. In England, we tend to refer to exposed thermal mass. I'd never heard of a TABS building until this presentation was first talked about. I think it's worthwhile just looking back on how we used to design buildings, because as Susan's already mentioned, building is an evolutionary process, and it needs to be. We need to learn from our mistakes and react to our environment. But we need to make sure that we don't lose things along the way. Back in the air-conditioned days, and they still exist, let's face it, we had ceilings in buildings. We don't have ceilings anymore. Ceilings are dead. Certainly in education, we don't do ceilings anymore. And Ecofon have adapted to that. And I remember, I think it's probably 2009 when I first saw a picture of the Master Solo with an inset light, and I thought, that's the future. And here we go. And now every school is being designed like that. That's now moving into offices as well. But I'm going to be thinking about offices mainly. So we used to have ceilings. We used to have mechanical ventilation. Mechanical ventilation is great from an acoustic point of view because it gives us a steady background noise. And we need steady background noise. If it's too quiet, an open plan office is dreadful. If it's too quiet, a cellular office is dreadful because you can hear everything coming from next door. And we had lots of glass. That causes more problems than anything else. Far too much glass, it just does nothing apart from win Sterling Awards. So the benefit of these old type of buildings was that we had lots of absorption in the ceiling. That's good, I think. And we had masking noise, which is good, I definitely think. The problems are we had overheating, and that's the problem with the glass. We had huge energy bills because we're having to cool down the solar gain that's caused by the glass. And generally, design was inefficient. Ceilings are an excuse for most engineers because you can keep all the messy stuff up there. Nothing has to look beautiful. Nothing has to look elegant apart from the ceiling itself. So it's a bit of a sloppy way of designing. Talking to Sue and I have never met until today, but we've talked a couple of times on the phone, and she introduced me to the concept of backcasting. I thought, what was that? And when she mentioned it on the phone, I was nodding and thinking, oh, yes, I know what you mean. Quickly Google, what does backcasting mean? But it makes a lot of sense. Forecasting is saying, OK, if we carry on the way that we're going, where are we going to get? But that's a bit of a defeatist attitude, isn't it? Backcasting is much better. It's saying, OK, well, where would we like to be, and then how are we going to get there? So where we'd like to be is not where we are now. We want to be in a place where we can ideally not have global warming, but let's face it, it's happening whether we like it or not. So we need to adapt to that, and we need smart buildings, and we need personalised environments, and all this kind of things. How do we get there? So I thought, well, what's a checklist for good design? What does good design mean? Well, we go for the S word, sustainable. I don't think many people realise what sustainable means. Sustainable isn't just green. You can have the most energy-efficient building in the world. It can have a huge wind turbine, it can be covered in solar panels, and it can be a useless building for the occupants. That's not sustainable. Sustainability is about having great buildings now, which are fit for the purpose that they're built for, without impeding the progress of the future and without compromising the future. So there's two elements. It's got to be for the now and for the future. And so we need to look at the energy impact of materials, smart buildings, buildings that can do a bit of thinking for themselves, but also buildings that aren't too complicated as well. Buildings that can look after themselves without too much intervention. Low cost, high value. That's what all our clients want, isn't it? Coordinated engineering. We're multidisciplinary engineers, and we pride ourselves on coordinating the engineering together. But really what we want, because we're not just engineers, are we? We're people. We have a sense of belonging. We have a sense of beauty as well. And we want buildings that challenge us. We like solving problems. We want beautiful buildings. We want articulate environments that speak to us of what they're doing. And we want to be inspired by our buildings. We want to, our buildings to inspire others. And that's certainly something that we've been pushing in schools for a while, and now it's moving into the workplace as well. But we mustn't forget the benefits of the past either. This an interesting building on the right. This is a typical ancient Middle Eastern building. Yet it's packed full of modern design features. How did they know? Quite small windows, very thick reveals so that we don't get too much direct daylight. Huge, big, thick walls, great thermal mass. Low-level air intake, high-level air extract. It's a naturally ventilated building. That was good, wasn't it? Yet we seem to have had a couple of thousand years of forgetting that good buildings were like this. So, I want to give you a case study. This is a very texty slide. It's very boring. You have some nice pictures afterwards. We recently moved offices in our Birmingham office. And because we're engineers, we wanted a building that did something that showed off what we were and what we did. But when we walked into this building, and I'll show you a picture in a minute, it was a wet-pressed mineral fibre Class D absorbent ceiling. 600 by 600 mil luminaires recessed. It had a very boring, very clunky 4-pipe fan coil ventilation system. It was boring, but it had great potential. And as engineers, again, we're trained and we instinctively look at the potential of buildings. So as a developer and as a client, what did we want? Well, we want a low-energy building because we want to be good for the planet, but also we don't like paying large bills. But also we want a collaborative workspace. It's interesting when you look at a lot of the research that's been carried out into offices. Back in up until the 1940s, everyone had their own little cellular office. Sometime between 1940 and 1950, people started to take the walls down. Yet all the acoustic design and all the research was trying to get back to an acoustic position that reflected when we had office walls in there. The problem is we don't work like that anymore. Well, we don't. We work in a collaborative environment. We work in teams. We want to be able to communicate with each other. And therefore the design and the research of BS 8233 and all those kind of standards don't necessarily apply anymore. We want to expose services because we're services engineers as well, and we like looking at the things that we design. We want things to work together, coordinated. And this is a really important one now. We wanted something to enable video conferencing. We don't have phones anymore at our desks. We have headsets and we have webcams. And we use a system called Microsoft Link. I'm an Apple man, so it grieves me to say that Microsoft is good, but Microsoft Link is good. Apple will do it later and they'll do it far better. But what it needs is for people to be able to communicate on a headset with a webcam at their desks. And that requires a certain amount of light as well. It needs cylindrical illuminance because you need to be able to see people's facial features. Otherwise, if facial features are in shadow, it looks evil. And we wanted a shop front for our design services so people could walk in and say, Cundall, what do you do? We do this. I know what you do now. It's telling us. So, collaborative working, but also we want privacy across the floor plate. It's a bit of a challenge. So the design was acoustic rafts. The only lighting in the office is task lighting. Task lighting over the desks. We've got 500 lux on the desks and no lighting in the corridors. It's about 100 lux in the corridor, but that's fine. You don't need a brightly lit corridor. Why pay to light the whole office floor plate at 500 lux? No one sits in the corridor. What's the point? Because we're in a city centre, we've got poor air quality. It's noisy outside, so we needed mechanical ventilation, but we also want mixed mode option as well. And we want to expose the soffit so we can make the building work for us and harness some of that thermal mass. And also we want a personalised environment. And so it is that we've got acoustic raft and acoustic absorption, which are local to where the people are sat. And also we've got lighting, which is daylight dimming, but also absence detection. So if no one's sat at a desk, the lights aren't on. So when we walked around the office, that's what we faced. And we thought, oh, it's horrible. But it had so much potential up above this ceiling, because as engineers, we go and poke the ceiling and we get covered in dust, 'cause it's old mineral fibre, horrible stuff. And there was a meter above there. What a waste. And so we thought, we're going to change that. And so we did, and we have. And these are our beautiful new offices. We're really proud of them. And it's such an inspiring place to work. As you can see, exposed services, coordinated services, and you can just about see over here, we've got the task lighting over the desks. So what's the subjective feedback from the staff? Well, people think it's great. Not just the people who helped design it, but people are raving about the acoustics. They say it's great. You can go and have a conversation with someone, and then you can't hear someone else's conversation. The best office I've ever worked in is a comment from one of the people, and that wasn't a graduate. It was someone who's worked in lots and lots of offices all over the world. And also, people walk taller. People are proud of the environment they work in, and that reflects in the way that they conduct themselves and the way that they carry out their business. It's well suited to video conferencing, but one of the key features to it all is that background noise is so important. It's a constant 43 dBA plus or minus 1 or 2 dB across the floor space. Before 8 o'clock in the morning and after 6 o'clock in the evening, that air goes away, and it's so noticeable. You can hear everything after that. You need to have background noise. And when we're in mixed mode scenario, we've still got the background noise because it's a bit city centre. We've got lots of noise coming in from outside. But there are some activities you just have to take into the meeting rooms. You can't talk about somebody's future promotion plans or their salary in an open plan office. It's just not compatible. So we did some measurements as well, because we're acousticians and we've got 2 minutes left to talk about all these things. So we like doing measurements because that's what we get paid to do, except we weren't paying ourselves to do this. So we measured reverberation time, although I put a question mark because reverberation time is useless in open plan offices, and we'll demonstrate that. We looked at STI, we looked at spread of noise. We tested to ISO 3382. Now, those of you who are not from the UK may be surprised to hear that we don't really do ISO 3382 in the UK. It's a bit too hard, and it takes a long time, and we tend not to use it. But we used it just to see what it told us. And the findings, really, in summary, are that we got privacy between clusters and communication within the cluster. So that's exactly what we wanted. But let's just look at some numbers. Just to prove that RT means nothing in open plan, this is a spread of reverberation time measurements across the floor plate. It varies from 0.35 to 0.55, which in itself is not a lot, but the pure spread means what we've always said. In an open plan environment, you haven't got a consistent reverberation time, and it depends where your source and receiver are. So forget RT, it's pointless. We did measurements, but also we created a model in Acoustic, because what I wanted to do was to look at a theoretical model against the actual model, and then to look at, well, what if we'd have kept a ceiling in there? And so we've looked at a Class A and a Class D ceiling option as well. We looked at D2S, LPAS4, and this is another reason we don't use them. It's far too difficult to say, and LPB. Interestingly, I mean, what that's really saying is when we look at the spatial decay of noise within a space, it doesn't really make much difference whether you've got rafts or ceilings. It's very similar, really, which is interesting to know. So less is really more. And similarly, there's not really much difference between LPAS4M in different scenarios. Very similar whether we've got Class D, Class A, or rafts. And it's borne out quite well by the in situ tests as well. And similarly for a different line. The most interesting one, and also one of the most pretty pictures, is looking at STI and how that works around desks. Looking at someone sat there, you can see that dark blue is an STI of between 0.6 and 0.75, so good. So we've got good communication within a speech cluster, getting to poor communication as we get between clusters. So that's exactly what we want. Notice the funny shapes. That's because we've got upstands screens between the desks and cabinets at the edge. similarly for a different position. And the privacy radius is about 6 metres. Privacy distance is about 13 metres. The distraction distance is 6 metres. So again, that works out with the kind of spacing that we've got for the desks. And looking at definition as well, again, you've got good speech communication, local, but it gets worse the further away you are from the listener. So what does this tell us? I think there's no two ways about it. Building design has changed. We wanted to design our own fit-out that reflected the way that we see buildings should be designed, not the way that they've always been designed, because that's not necessarily good. As Sue was saying, buildings now need to be building-led, not systems-led. The building needs to be made to work for you, not artificially making it so. And there are plenty of good examples that we could talk about. Google, what they've done at Google Docs in Dublin, which is a fantastic space. Completely bonkers, but really great. This is a project we're working on at the moment for a local authority council where they've got a courtyard area which we're enclosing with an ETFE roof and taking all the windows out. The building will breathe, whereas at the moment it doesn't. And really, the problem we have in the UK is that we develop buildings to Cat A, which means that you build them so that they've got ceilings in and carpets, and that's how a tenant receives it. That's pointless, because when a tenant comes in, they rip all the ceilings out and do their own thing. It's completely wasteful. We need to challenge that culture and go for shell and core. And really, dare to be different. Don't do it because people have always done it, because that doesn't mean that it's necessarily good. So I look forward to hearing what you've all got to say. It should be a really good couple of days, and now it's your turn. Thank you.